Hello everyone. My name is Li Hao, and today we're going to do Advent of Code 2020. So, Advent of Code 2020 is a series of programming challenge on an Advent calendar, which on every day on the calendar, there's one programming challenge, and there's two parts of it, and solving each part, you get one gold star, and at the end of it, you will get 50 gold stars if you can clear all of them, right? So today we're going to do day 12. Do you know what that means? It means that we've been doing day 1 to day 11. So if you're first time watching this video, please click on the link over here. Ding. Okay, so let's head to day 12. So let's go to the calendar. Let's click day 12. So day 12, rain risk. Well, your ferry made decent progress towards the island, but the storm came in faster than more anyone expected. The ferry needs to take evasive actions. Unfortunately, the ship navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. When the captain uses a PA system to ask if anyone can help, you quickly volunteer. The navigation instructions, which is your puzzle input, consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. Well, action N means north, S is south, east is east, W is west, L is left, given the number of degrees, R is right, F is forward, given the direction and the ship is currently facing. So the ship starts facing east, so left and right actions change the direction. Okay, so if the ship is currently facing east and the next direction is north 10, it will move north 10 units, but still move east if the following action is F. So F is forward based on the direction you're facing, right? So F10 is to move forward 10 units east, N3 is to move 3 units north, F7 is to move ship 7 units east because you're still facing east. R90 is to turn right 90 degrees, so now you're facing south. F11 would be moving the ship 11 units south, right? So because you're facing south, 11 units to the south. At the end of this instruction, the ship's Manhattan distance, which is a sum of absolute values on both the east-west position and its north-south position. So it's we are at east 17, south 8, so 17 plus 8 is 25. So figure out the navigation instruction and what's the Manhattan distance between the location and the ship's starting position. To begin, this is our puzzle input. Let's copy it, or no, let's save it. Input text. And let's move that code to day 12. Let's create a new day 12 file. Start with it. Okay, so first thing first, let's take a look at our input. Usually there's a new line at the very end which causes some issue. New empty line, as you see here, is what I try to remove it. And okay, so this is the instructions. Every direction instruction necessary in one new line. So I'm gonna read it out first, and I'm gonna read out as text, and I'm gonna break it by new line, and I'm gonna loop through each of the instruction. I'm gonna do something about it. Okay. So the instruction consists of instruction or direction and the amount, right? So we can use regex to split those things out. So first is the direction, and then the next one is the amount. So instruction.match so character, which is north, south, east, west, or forward, and we need to capture it. And we also capture the number D. Okay, north, south, east, west, forward. Okay, so now we have it. So probably the first thing is amount in number. So actually we need to convert the amount into number. Okay, and then we need to keep track of two things: the current direction, right? So let direction and equals to, so we are facing east, right? So I'll represent it with ones and zeros based on the direction that we're pointing at. So if it's east, then it will be on the x-axis, it's positive. Okay. Sorry, to the right is on the screen. Sorry, the camera is a mirror, so to the right I presume is here. So left to right. So left I will pick, towards the left I would say it's a -1, and towards the right is positive. So east is 1, and then north south is actually 0 amounts of facing anywhere, right? So this is a current direction. I say current direction. And then we also need to know like the amounts that we have moved in those two directions. So distance moved equals to 0, 0. Okay, so we are moved to we're still in the origin. Okay, so now let's look at each of the instruction, and we do handle each of them, right? And at the end of it, what we need to do is just console out distance move, x direction, x, and also y, to sum it up, and that will be our answer. So first case is north, right? So if that's the case, then distance move 1, we'll have to minus the amount in number, right? Because move up is negative, down is positive. That's how our direction is. So from the top left all the way to down, bottom right will be moving positive. So up is negative, down is positive, left is negative, right is positive. Okay, break. So case south, then we are doing the same thing, but it's adding. Okay, and we are probably doing the same for the east and west. So east is positive, west is negative, and we're adding it to the x-axis. Now, there's a left and right, right? So left, right, left. Then we're actually gonna rotate. Okay, so I'm gonna call it rotate. A function called rotate towards, so left is, I would say, again moving left is, I would say, it's like a negative turn, and rotate right is like a positive. This is how I just define, and I just make sure that it everything just follows that, right? You can say it's positive or up to you, but I will call it a negative, and I try to make the code work accordingly. Break. Then lastly is the forward, which move forward in terms of direction that we're facing, right? So direction moved 0 is equals plus equals to the current direction 0 times the amount in number, and break. in case, I think that's all. And of course, we need to move both x and y axis. And the rotation actually takes a degree as well. So what I'm going to do here is I need to amount a number. And actually, if you take a look at the example, you're moving left and right in the multiples of 90 degrees, right? Actually, 90 degrees is moved like one tick of position. So I believe there's no like 45 degrees kind of thing, right? So actually we can check that, right? So left, right doesn't seems to have in between 90 and 80, right? It's a more of a multiple of 90 degrees. Right, so what I do here is I'm gonna divide it by 90. Right, so that I can get I think make it easier is I also times, okay, like this. Right, so now it's like -1 if it's 90, -2 if it's 180. And same thing goes for R. Rotate for R. So now we need to fill up the rotate function. Rotate degree, or I would say turn, right? Half turn. So how much of a turn that you do it? So first thing is that we need to normalize the degree itself, right? If it's 360, it's actually 0, right? So what that means is that turn equals to turn modulo of 4, right? So if it's if you turn more than 4, if you are 5, actually is equals to 1. So modulo of 4 will give you just like limits. It will wrap it around and back to 1. And then if it's negative, if turn is negative, then we go +4, so that we wrap it to make it positive, right? Then the possible value of turn would be 0, 1, 2, 3, and so switch turn. Okay, so 0 you can just ignore, we're not turning anything. 1, 2, 3. Okay, so I'm gonna have each of these case. So case 1 is that we are moving like this, right? So the north becomes the positive of north become positive of east, right? So direction, so positive of north is actually a negative y value, it becomes a positive of x value, right? So we're gonna, the direction of x is actually a negative of direction of y, right? And then y, positive value of y will have the value of x actually, right? So they are positive and positive direction of I equals to direction of 0. Okay, so case 2, okay, so what if I do it this way? Actually I've already changed the direction 0. At the same time it has already become this. I want to change both of these at the same time. Instead of changing the value of direction 1 after 0, then actually end up I will have direction 1 equals to the previous value of negative direction 1. So I can do it in a bit of a cheat in JavaScript, which is like a array destruction. We are destructure. I'm going to destructure this at the same time. So when you do the structure, the value of this 2 will be assigned to this 2 at once. Okay, so yeah, so the 0 and the 1 will based on the before this assignment, based on the value of direction 1 and 0 right before this assignment. So I'm going to kind of copy this over because we're going to follow this way of writing. So if it's 2, it's moving all the way opposite, right? So which means is that it'll be a negative of 0 and negative of 1. And we are moving 3 is actually moving 3/4 turn of a circle, which is almost like this. So again negative. So the y will be, the x will be the y value, and the y value will be the negative of the x value. Okay, so I believe this is it, and let's take it a run. Node code day 12. Direction. It's called a current direction. Oh no. Okay, so I'm gonna replace this quickly. And I'm gonna go. Wait, this is not good. Okay. So probably we either move north, south, east, west, right? What we want is the Manhattan distance, which is like we want the absolute value of the y distance and the absolute value of the x distance, right? Because we don't want the y distance offset the x distance. So let me clear this and run this again. 1710 looks like a good number. Gonna paste it in. Yes, that's the right answer. And let's move on to part 2. So before you can give the destination to the captain, you realize that the actual actions meanings were printed on the back of the instruction the whole time. What? You didn't even read it? So almost all the action indicates how to move a waypoint which is relative to the ship's position. So N means to move the waypoint north by a given value. S is to move the waypoint south. Okay, so E is waypoint east, W is waypoint west. L is to rotate the waypoint. R is rotate the waypoint to the right. And F is to move forward to the waypoint a number of times equals to a given value. Right, so the waypoint starts with 10 and 1. 10 to east, 1 to north. So if the ship moves, it moves number of waypoints of it. So forward 10 is to move 10 waypoints, which is 10 of 10, which is 100, and 10 of 1, which is 10 units north. Right, north 3 moves the waypoint 3. So now your waypoint is 10 and 4. So you don't move, but you remain the position, but you change the waypoint. So for F7 is to move waypoint 7 times, right? So it's to move 70 units of this, and 7 times 4 is 28 units of north. Okay, so okay, I think we roughly get it. So after these operations, the ship Manhattan distance from its starting position is this, and again we are going to find the Manhattan distance between the location and the starting position. So we need another array, which is the waypoint, and it starts with 10 units to the east and 1 unit to the north. So north is negative to me, right? -1. So okay, so I think there's no such thing as a current direction anymore. Okay, how about so I'm gonna replace all current direction to waypoint, because I'll remove this, because the rotation logic still stays the same. We are rotating the waypoint, right? And the forward, okay, so let's go one by one. So north is actually not moving the distance, but moving the waypoint. So south is same thing as well. We rotate the waypoint, which is good, and the distance is the waypoint times the amount in number, which is correct, right? So let's try this. 62045. Yes, that's the right answer. And we solved day 12. Right, so if you like this video, please click thumbs up. If you feel that I have something that I can improve on, please feel free to comment down below. And that's all for today. If you want to watch day 13 and onwards, please remember to subscribe to my channel so that you get notified when a new video is out. So see ya!